Good day, I'm here to report about geothermal power plants. Geothermal power plants are used in order to generate electricity by the use of geothermal energy, the Earth's internal thermal energy. They essentially work the same as a coal or nuclear power plant, the main difference being the heat source. With the geothermal, the Earth's heat replaces the boiler of the coal plant or the reactor of a nuclear plant. Hot water or steam is extracted from the earth through a series of wells and feeds the power plant. In most geothermal plants, the water pulled up from the ground is returned back to the subsurface. The rate of water used is often larger than the rate of water returned, so make-up water supplies are generally needed. Geothermal power is energy derived from the heat of the Earth's core. Geo means the earth and thermal means heat. This type of energy is clean and predictable, offering a reliable and renewable energy source. There are three types of geothermal power plant, which are the dry steam power plant, flash steam power plant, and the binary cycle power plant. Known geothermal power plants. The Geysers Geothermal Complex. The Geysers, comprising 45 square miles along the Sonoma and Lake County border, is the largest complex of geothermal power plants in the world. Calpine, the largest geothermal power producer in the US, owns and operates 13 power plants at the geysers with a net generating capacity of about 725 megawatts of electricity, enough to power 725,000 homes or a city the size of San Francisco. Philippines geothermal power plants. The Philippines is the world's second largest producer of geothermal energy for power generation. In fact, it is home to three of the top 10 biggest geothermal power plants in the world. The Philippines is located within the Pacific Ring of Fire. This implies that it is prone to intense volcanic activity and earthquakes. Number 1 power plant in the Philippines is the Macban Geothermal Complex. The Macban Geothermal Power Plant is located in the southeast of Manila, Batangas provinces. The plant is owned and operated by AP Renewables, a renewable energy developer in the country. Mitsubishi Power has delivered the first geothermal power generating unit in 1979. It is produced It produces 458 megawatts output capacity. Number 2 is the Tiwi Geothermal Complex. The Tiwi field has an installed capacity of 275 megawatts of electricity and is located about 300 kilometers southeast of Manila in the Albay province. Exploration began in 1964 and power was first generated in 1979. By 1982, Tiwi became the world's first water-dominated geothermal system to produce more than 160 megawatts of electricity. Third is the Malitbog Geothermal Power Station. The Malitbog Geothermal Power Station is a 232.5 megawatts geothermal power plant or an earth steam turbine electric generator, the world's largest geothermal power plant under one roof located in Malitbog, Canangac, Leyte, Philippines. The power plant is one of the four operating in the Leyte geothermal production, and it is the first geothermal power plant built in the Philippines. Advantages of using geothermal. Number 1. Environmentally friendly. Geothermal energy is more environmentally friendly than conventional fuel sources such as coal and other fossil fuels. In addition, the carbon footprint of a geothermal power plant is low. While there is some pollution associated with geothermal energy, this is relatively minimal when compared to fossil fuels. Number 2, renewable. Geothermal energy is a source of renewable energy that will last until the earth is destroyed by the sun in around 5 billion years. Number 3, huge potential. Worldwide energy consumption is currently around 15 terawatts, which is far from the total potential energy available from geothermal sources. While we cannot currently use most reservoirs, there is a hope that the number of exploitable geothermal resources will increase with ongoing research and development in the industry. Number 4, sustainable or stable. Geothermal provides a reliable source of energy as compared to the other renewable resources such as wind and solar power. This is because the resource is always available to be tapped into, unlike with the wind or solar energy. Number 5, heating and cooling. Effective use of geothermal for electricity generation requires water temperature of over 150 degrees Celsius to drive turbines. Number 6, reliable. Energy generated from this resource is easy to calculate since it does not fluctuate in the same way as other energy sources. This means we can predict the power output from our geothermal plant with a high degree of accuracy. Number 7, no fuel required. Since geothermal energy is a naturally occurring resource, there is no fuel to be required. Number 8, rapid evolution. There's a great deal of exploration into geothermal energy at the moment, meaning that the new technology are being created to improve the energy process. There are an increasing number of projects to improve and grow this area of industry. Disadvantages of geothermal. Number 1, location restricted. Geothermal plants need to be built in places where the energy is accessible, which means that some areas are not able to exploit this resource. Number 2, environmental side effects. Although geothermal energy does not typically release greenhouse gases, there are many of these gases stored under the Earth's surface which are released into the atmosphere during digging. Number 3, earthquakes. Geothermal energy also runs the risk of triggering earthquakes. This is due to alterations in the Earth's structure as a result of digging. Number 4, high costs. Geothermal energy is an expensive resource to tap into, with price tags ranging from around 2 to 7 million US dollars for a plant with a 1 megawatt capacity. Number 5, sustainability. In order to maintain the sustainability of geothermal energy, fluid needs to be pumped back into the underground reservoirs faster than it is depleted. This means that geothermal energy needs to be properly managed to maintain its sustainability. Site selection. The geothermal exploration method seeks to capture a wide range of geoscientific data at a local and regional level. Informations can be obtained through the analysis of a well log data, temperature logs, magnetotelluric data, and gravity or ground deformation studies. Engineers have developed a tool to help planners and designers decide on the exact location for well planning and site development. A detailed 3D model developed through the integration of relevant geoscientific data allow well planners to easily locate and design the well path. Depending upon the decision, the well should be located nearby for facilitating proper transport of geothermal fluids. This is the sample power plant layout. Main components of geothermal power plants. Number one is the geothermal vents. The geothermal vent is the first component of geothermal plant. A geothermal vent is a deep well drilled into the earth that the power plant uses to tap into the earth's heat. A geothermal plant may have two goals for its vent. Most current geothermal plants draw superheated, pressurized water upward. These are called flash steam plants. Geothermal plants may also simply dig far enough underground, as many as 3 kilometers, to reach a point where the earth is warm enough to boil water. These are called dry steam vents. Number 2. Steam generator. Another key component of geothermal plant is the steam production unit, which can take multiple forms. In flash steam vent, superheated pressurized water is drawn from its place underground to low pressure tanks. The pressure of the earth keeps the water in liquid from despite its high temperature, and by removing the pressure, the high water instantly turned to steam. Hence, the term flash steam. In a dry steam plant, the technicians pump water to the bottom of the vent where the earth's heat boils the water and turns into steam. Turbine. Regardless of the plant type, both flash steam and dry steam plant pumps the steam from the geothermal vent to a large turbine. The steam passes this turbine, turning it in the process. This turbine is attached to an electric generator, and as the turbine turns, the generator turns the mechanical energy into electric energy, thus converting the heat from the earth into usable electricity. Number 5. Condenser. After the steam passes through the turbine, it continues to a condenser chamber. This chamber condenses the steam back into liquid water by cooling it. The excess heat lost as the steam turns to liquid. Water may be used for other applications, such as heating or greenhouse farming. The cold water is typically pumped back into the ground to either restart the boiling process for dry steam or to replenish the natural heated aquifer for flash steam plants. Thank you for watching.